So today will be a short video on how to work with very large databases. So here are some links. Usually when a database is less than 5 terabytes, you don't need a distributed database, and any SQL database can handle it. You can use well, MySQL, PostgreSQL, Microsoft SQL Server, doesn't matter. You don't need clustering, and things will work. Well, with clustering, of course, it will be better. But what if you have database which is in tens of terabytes or hundreds of terabytes, up to maybe, I've seen 2 petabytes. That's the most I have seen. I'm talking about SQL database. So here are some links. For example, for Azure, there is something called Azure Hyperscale, and it is up to 100 terabytes. And then there is Azure Premium, which I spoke to a colleague. He said he's seen 500, 700 terabyte databases. And if you look historically, just a few years ago, the databases were much smaller. On one of the previous lectures, I mentioned this company. They have geographical data. They track people using their cell phones. And every day they get close to terabyte of compressed data, and they have about 2 petabytes of storage. So they're using Google BigQuery, and they're using all tricks in the book to split their data in pieces so they can query faster. Right. So when you talk about big data, you have to think about, these are examples of what kind of events those big tables may store. And you have to focus on performance, how you query, update, maintain, and manage, like archiving and so on. So it's a complex problem to build and maintain a big database. This is example of a BigQuery. The main point I want to say that big databases need to be built using distributed architecture. You cannot run it on one computer. I mean, you can scale on one massive computer, you can scale it only so far. And then you have to distribute. BigQuery is a good example of a distributed system. There are some alternatives. One is like Apache Drill and Presto, and Amazon Athena. It's actually simply Presto, but put on Amazon Cloud. It's like a hosted version of Presto, but they all are not as good and is not as price effective as BigQuery. And the reason why BigQuery is cheaper, one of the reasons is because they charge differently for, like some databases charge for compute and for storage. BigQuery charges for the data you touch in your queries. So if you structure your data, like if you shard it, distribute it, subdivide it, let's say by date, and you only query the recent data, for example, then you will be charged less. So it's very interesting. A different charging scheme. Yeah, and by the way, BigQuery is SQL compatible. So if you want to do data warehouse in Google Cloud, BigQuery will be your first option. Okay. So these are examples of BigQ. BigQ means BigQuery. So create table, partition by, and you can partition by transaction date. Until recently, you could only partition by date, but now you can also partition by integer. And I spoke to the main developer at this company, and what they do, they have geographical location, longitude and latitude. They convert them into integers, and then they can partition by both dates and by geographical location. So it really helps them to make their queries faster and to cut the cost. And by the way, I spoke to them. I asked, have they tried other databases? And they did. They tried on Amazon, and they tried Spark. Well, they didn't try Spark. They have a competitor which uses Spark, and their cost is like 3 times more than BigQuery. So it looks like BigQuery, at least today, is the winner in terms of cost performance. This is example of Azure Hyperscale Tier database. So what you see here, you have multiple data files, right? You have caches, you have page servers, and then you have compute, and it's all distributed, right? Again, I just put this image just to demonstrate that the database is heavily distributed. And I'm not even sure if hyperscale tier is similar to standard tier. So the Azure Data Warehouse, it has 3 tiers: standard, and then I'm not sure how much it can grow. Then hyperscale can grow to 100 terabytes. And then above that, so maybe 500 terabytes or more, it is premium. And I'm not sure what's the architecture of this premium layer or hyperscale layer. Maybe it's like, you know, standard has parallelization of 60. So maybe this hyperscale layers and up, they have like higher parallelization. I don't know. I already shown this slide. So it's kind of development of databases from row-based to column-based for analytics, for massive parallel. This is example of Azure Data Warehouse. In memory or GPU-based databases, again, massive parallelism is achieved because GPUs have a lot of cores, right? And then Polaris, which is what used in serverless, in Synapse serverless. So you have thousands of data cells and compute nodes. Hadoop Spark, as I mentioned, it's good, it's performant, it's convenient, but it's more expensive than, for example, Google BigQuery. And there are other databases. Okay, in Azure Data Warehouse, so here are some links how you create a table. And what I want to show you is that you can create it with the index, right? But you can also create it with index and distribution. The distribution here is round robin or hash, and which one to use, it depends on what you want to achieve. Clustered index. I want to show what it is. Let me move this slide here because we haven't spoken about indexes so far. So in the old life, like 20 years ago, data was stored in data rows. And then for fast searching, for fast querying, people used indexes. So, and indexes are trees. And you could create index for any column or combination of columns in particular order. Like, for example, maybe index for first name, last name, or for last name, first name. It will be 2 different trees. There is one index which is very special, which is called clustered index. And this is index, which is a tree, but it actually contains all the data. So this is, and that's why it's only one. This is the actual data is stored as a tree. And when you create a table, you can define its clustered index. And this usually is used for the most common query you want to run on this table. Okay, so we have table indexes to search within the table. But again, it's only usable when data is stored as rows, because in columnar storage, indexes are columnar indexes, and like compressed in memory, completely different technology. Okay, different topics. Suppose you have a star schema, and the central facts table is very big. So, and dimensions are small. Then you can distribute the central table between many nodes, and you can replicate, mirror the dimensions. So dimensions in all nodes. So below we have nodes. So dimensions are the same in all the nodes. And the fact table, the event table, the central unit here is distributed. So this is part 1, this is part 2, and so on. So this way, when you do regular analytics, when you join facts to dimensions, its join will work fast because it will use the tables which are in the same node. Okay, what's happening here? You see example of distribution done by hash, right? And then we have partition by something. Is it a date? No, it's not a date. I'm not sure what it is. Hold on. Yeah, order date key. So some sort of key. And here on the right, there is an example where you have two fact tables, and the question is how you distribute them between nodes. So here we have 3 nodes, and below you distribute them by the same hash. And then when you join them, you see all joins will be in the same node, because the same ID by hash function will be put in the same node for both tables. But if you use round robin, then they go randomly, and then when you do the join, they'll have to move data between the nodes, and the query will be extremely slow. So you need to think about what kind of queries you will need, what kind of joins you will need, and based on that, how you distribute your tables between the nodes. Okay. Facebook. It's really interesting because if you look at this website, Facebook generates 4 petabytes of data per day. 4 petabytes, quite big, but it's not SQL storage. They store it as Hive, which is basically key value store, and they approximately store 300 petabytes of data, right? Also interesting that for their reporting and a lot of other purposes, they use MySQL database as their main storage. They tried many different databases and they still may use them, but MySQL is their main database, and they created their own engine for MySQL database. Originally, they used something called InnoDB, and this is a transactional engine for MySQL. But then they created MyRocks, which is better, faster, takes less memory, achieve better compression, and that's their main engine. Sometimes people think of MySQL that it's not a serious database; it's like a toy open source database. But come on, like Facebook is using it, and it's their main database. Okay. And the last slide I want to say about ClickHouse. So there is a company called Yandex, which is kind of Russian Google. And they have search engines, they have Yandex Maps, they have Yandex Taxi and Yandex Stores and Yandex everything. And they created a lot of good software. For example, for machine learning, I know they created a boost algorithm called CatBoost. And for database, they created ClickHouse, which will have some record-breaking performance. I provided here the links. Usually everything about Yandex means that it's very, very scalable. Well, think of Google, right? It's a big scale, a very big scale and high performance. Distributed under the hood and so on. So they made it open source 5 years ago, so it's under Apache, and I highly recommend to look at it, because for whatever reason here, most people don't even know about it, but it's very good technology. Yeah, I want to say about one more database solution, which is called Firebolt. And this is a very, very interesting database. It was developed by this company, Firebolt. Eldad Farkash is the founder of this company. It's based in Tel Aviv, and it has a star team, some from Google who were creating BigQuery. And so this database was created on Amazon. So it's using S3 files for storage. And it is much, much faster than other databases and also much cheaper. So here it says that it's almost 200 times faster than Athena. And here you have comparison between Snowflake and Firebolt. And you see that the cost is 10 times difference. So Firebolt is literally 10 times cheaper. And you see how much faster it is for like 5 different queries. So you see speed up like almost 400, 800 times, 50 times, 6,000 times, 50 times. So it's an amazing new database. Here there is a short YouTube video which shows a query of 42 billion rows in less than 1 second. And here is about 40-minute presentation where Eldad at whiteboard presentation explains how things work. Really, really interesting. So the database combines the best of features you would wish you have in a data warehouse. It is SQL compatible, it's very fast, it's scaled unlimitedly into petabyte ranges. It's very easy to scale it up and down. And people claim there's a lot of positive feedback. People have sub-second response in their dashboards. Like, for example, they're using a Google Looker and they querying billions of rows and they have sub-second response refreshing their analytics screen. So it's absolutely amazing database. I highly recommend you to read. This article explains a lot about it. It was about like 1 year ago. So that's it. It's very, very exciting.